Hi. Hello. Uh, I know you will have studied certain basics of number system in my previous classes or my previous videos that I have uploaded. Now, for by this time, you might have understood what is rational numbers, what are whole numbers, what are positive numbers, what are negative numbers, what are integers, and whole set of this on the number system, and representing them on the number system is also being told to you. How do you locate them on the number system, and how to find out rational numbers between any two given numbers or two given rational numbers or not, or whole numbers or integers. So you've understood all that. So let me just give you a small recap of rational definition of a rational number. So when we define a rational number, how do we define a rational number? We define rational number in this fashion. Just hold on. Okay, we define rational number is a number which can be expressed in the form p by q, where q is not equal to 0 and p and q belong. This is a symbol that indicates in mathematics, which we use to denote belongs to the set of integers. So let me repeat, rational numbers are the numbers which can be expressed in the form p by q, where q is not equal to 0 and p and q belong to the set of integers. Now when I say the set of integers, what does the set of integers have? The set of integers has 0, it has all the numbers, positive numbers at the positive end, and all the numbers towards the negative end. So this forms a whole set. So this p and q can either be from this end, or it can be 0, or it can be, but q cannot be 0. P has the freedom to have any of these values, but q also has the freedom except this 0, because the definition denies that it should be 0, because any number divided by 0 is either undefined or infinite, right? So now that you've understood the definition of rational numbers, it is now important to understand what are the next set of things that you have to understand. When I say there are rational numbers, obviously there should be something called irrational numbers, right? Because when you have positive numbers, you'll have negative numbers. So when you have rational numbers, you also should be having irrational numbers. Now the question is, how do I define irrational number? An irrational number is a number which cannot, mind you, I stress on the word cannot. An irrational number is a number which cannot be expressed in the form p by q, where q is not equal to 0 and p and q are integers. The whole definition is as equal, same as that of a rational number. But in a rational number, you can express it. I repeat, you can express a given number in the form p by q, and if it can be expressed, it qualifies to be a rational number. If it is not able, if it does not qualify, it's not possible to express a given number or an integer in the form p by q, then we classify these such numbers as irrational numbers, because they do not qualify as rational numbers, because they do not satisfy the condition of being able to express in the form p by q. Now what are the examples? So the examples are, say, root 2, root 3, right? Then you have root 5, root 7, root 8, root 10, root 11, and so on. Square root, I mean to say. Square root of all this. Or even say cube roots also. So these are digits, numbers which cannot be expressed in the form p by q, and that is why they qualify as irrational numbers. Now the question is, you have even pi. If you see the NCERT textbook of yours, It also indicates pi as an irrational number. It is not a rational number. But at this point you will have a confusion. Why is pi an irrational number? Because I am able to express pi in a rational form by saying 22 by 7. That is the standard definition of pi. We say pi is equal to 22 by 7. But let me make it clear to you. 22 by 7 is the value that has been agreed upon on a general consensus about from all the mathematicians all over the world to ease calculations. But the actual value of pi is not 22 by 7 itself. It goes on to 3.142, 144285 dot. Keeps on. It doesn't end. It keeps on unending. So just for the convenience sake, just for to make it easier for calculation, we have just approximated the value of pi as 22 by 7. But 22 by 7 it cannot be considered to be the exact value of pi. So if you take 22 by 7, yes, pi qualifies to be a rational number, but actually it is not 22 by 7. It continues to be 3.14285 dot. It continues. It is not the same number because 0.1, then you have 4, then you have 2, then you have 8, then you have 5, then you have so many other difference in digits. That is why it's a non-terminating and different digits, not the similar pattern is followed. That is why pi qualifies to be an irrational number, not a rational number. Right? Now let us, for example, if I give you a set of numbers, you need to understand. Before that, I would like to introduce it to you the basic criteria of rational numbers and irrational numbers. For example, I take the number, I take some certain fractions. Okay, let me take up some. So I take the fraction 22 by 7, 2 by 3, 3 by 2, and 1 by 5. So let me repeat. I take the fraction 22 by 7, 2 by 3, 3 by 2, and 1 by 5. So let's start dividing it. So I have said 22 by 7. I repeat, 22 by 7. 7 3s are 21. 1 is a remainder. I put a point, add a 0. 7 1s are 7. 3 is the remainder, add a 0. 7 4s are 28. 2 is the remainder, I add 0. 7 2s are 14. I 6. Add a 0. 7 8s are 56. 4 is the remainder, add a 0. 7 5s are 35. 5 is the remainder. It's so on. You find that this is not ending anywhere. It's not terminating. It keeps on dot. It keeps on going. I don't know how long we'll have to do it. So this is a non-terminating series. This is a non-terminating and not repeating also. You can see this digits are changing. It has 1, then after the criteria of rational numbers come only after the decimal point. So you see 1, 4, 3, 8, 5. So the number is not terminating also and not repeating. Now let us take 2 by 3. So when I say 2 by 3, okay, so when I say 2 by 3, I take, so since 2 is, I put 0 point, so I'll again do it once again for you, because I've done it earlier. I will do it again. 2 by 3. So 3 cannot go, so I put a 0, and I put a dot, then I add 0 to this. 3 6 18. Okay, 2 is a remainder, add another 0. 3 6 18. 2 remainder, 0. 3 6 18. 2 is the remainder, and so on, and this goes on. So you can just see this pattern of 6 keeps on repeating. So that is why we can just see it keeps on repeating like this. So this is not terminating, but the pattern is repeating. Not terminating, it keeps on repeating. The pattern is repeating, and it is in mathematics we represent repeating patterns by writing the pattern, and on the top you will put a bar. So this represents a non-terminating pattern maintained. Pattern maintained. Okay. You can see the pattern has been 6 6 6 6 6 6. So it's a number. You know the next digit also will be 6. Next digit also 6. So you'll know that the pattern is repeating. Now let me take 3 by 2. When I say 3 by 2, 2 1s are 2, 1 remainder. I put a point in 0, 2 5 are 10. So this is ended. So this is a terminating. It has terminated. If I take 1 by 5, that is 10. Again, if I divide, say 1 by 5, I put a 0 dot 0, 5 2s are 10. So it has terminated. So this is also, so these has terminated. That means to say this 2 by 7, 22 by 7, we say it is non-terminating and non-repeating. That is why non-terminating and non-pattern repeating fractions like this are called as irrational. They qualify to be irrational number. If it is terminating, in this case it is in these two cases it is terminating, they all qualify to be a rational number. And even though it is not terminating, the pattern has been repeated, it qualifies to be a rational number. Okay, rational numbers are the numbers when you have which have the if it is terminating, it is straight away it is a rational number. If it is not terminating but a pattern is repeating, then also it qualifies to be a rational number. If it is not terminating and there is no pattern, then it qualifies to be an irrational number. So let us consider certain patterns. So you have 1.6. So in this C 1.6, it is terminating at it ends. So this qualifies to be a rational number. If I write say 5 can be represented as 5.0. So it is terminating, so it qualifies to be a rational number. If I say 6.793, it has again terminated. There is nothing, so it qualifies to be a rational number. Then 6.793, there's a bar. When you say there's a bar, it repeats 793, 793, 793. So there's a repeated same pattern. That is why it qualifies to be a rational number. Then if I say 6.793 dot dot dot, that means to say if you just see the digits 7, 9 and 3 here are different digit and the pattern is not repeating, it goes on dot 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 dot. I don't know what it is. So it qualifies to be an irrational number. So I can say Q dash. I'll write Q dash. It qualifies to be this is an irrational number because there is no standard repetition. It's non-terminating and there is no standard pattern of repetition. If I say 0, 0 can be represented 0.0. So it has terminated. So it becomes qualifies to be a rational number, right? Because it is terminated. Now if you see 2.6